First problem, is it a function and does it have an inverse? Is it a function is a question you can answer with the vertical line test on a graph, okay? Is it a function? Yes, this one's a function. Yes, it's a function. Does it have an inverse is a question that you would answer with the horizontal line test. If you hit a horizontal line test and it goes through more than once, that's not one-to-one. This is not one-to-one. And so what that means is there's no inverse. So is it a function? Yes. Does it have an inverse? No. Next one, is it a function? Well, each x has to go to 1y. I look at it as you plug in x, you get 6. You plug in 2, you get 4. That's cool. That's a function. When it wouldn't be a function is if your 1 split and went to 4 and to 6. That would be bad. I plug in 1, I get 4. You plug in 1, you get 6. That's bad news. That would not be a function. That's not what we have here. As for the other question, does it have an inverse? You have to go backwards. You have to switch x and y kind of, and you think about, well, each y comes from one x. And so when that would be a problem is if you had 2 different x numbers going to the same y number. That would be a problem. Okay, we don't have that problem here. Each x goes to one y, each y comes from one x. This is one-to-one, this is one-to-one, so this has an inverse. Give domain and range, all right? Domain and range. So domain is where you squash it onto the x-axis. And if you look at this graph, if you squash it onto the x-axis, it's going to cover everything. So the domain is all real numbers. The range is if you squashed it onto the y-axis, and if you squashed it onto the y-axis, it's going to cover everything from here up. So that looks like -3 and up. The range is from -3 to infinity. This one, domain. A lot of us like to think of domain as the x numbers. It'd be 1 and 2. The range, 4 and 6. This one, it's kind of hard to tell. It's kind of hard to tell without looking at a graph. If you looked at a graph, it'd be easier. I know this is a square root or an eyebrow function that's shifted left 2. So if you look at a graph, 1, 2, if you draw that graph, it's a little bit easier to see. It's pretty easy to see your domain and your range when you're looking at a graph. Domain is your x number that starts at -2 and goes to infinity. Your range is your y number that starts at 0 and goes up. If you squash it onto the y-axis, it goes from 0 to infinity. Those are the y numbers that are possible. The possible x numbers in this are -2 to infinity. The possible y numbers are 0 to infinity. Okay, if you think about it, you can't plug in a -3 there. You plug in a -3, you're going to get a square root of a -1. That's not going to work. You can't do -2.1. That's going to give you a square root of a negative. But if you do -2, you get square root of 0, which is 0. That's fine. So as soon as we get to -2 and anything that's bigger, that's going to work. That's what domain is. What is discontinuous? So discontinuous is when, if you try to trace this graph from left to right, you're going to get to a spot where you have to pick up your pencil and jump over to the other spot. Okay, that's discontinuous. This graph is discontinuous. So a point about this graph, when we graph it by hand, normally we're going to put arrowheads on the end to show that it goes on forever. Okay, when you see this on like a graphing calculator or on Desmos or on the test, if it just goes up to the edge of the graph, assume that that means there are arrows there. If it's supposed to stop, there's going to be something obvious that makes it stop, like a point. Okay, it would need a point here or something to show you and tell you that it's going to stop. If it doesn't have that, you can assume that it keeps going. We just ran out of room because we're out of the graph space. Okay, so if you had to do domain and range on this one, it's kind of interesting. Domain, this piece squashes to right here. If I squash that piece onto the x-axis, it looks there. If I squash this piece onto the x-axis, it fills in that circle. So the domain on this one, everything gets filled in. The range, though, this piece comes over here and you leave this open, but that piece covers up everything. So it doesn't really matter. It doesn't really matter that this piece comes here and also covers up that much. It doesn't matter because that purple piece, that first piece, covers up everything from, where was that? 1, 2, 3, 4, 5, 6, from -6 and up. Now notice it is an open circle. So the range is going to be a parentheses from -6 to infinity. Evaluate f of 3. F of 3 on the graph. So you go 1, 2, 3. That's your x number. And you look at what the y number is. In this case, that's 4. F of -1. So sometimes people get fooled by this one. -1 is right here. And so they don't know which one to look at. But remember, an open circle means we don't count that. We're looking at the filled in circle. We're looking at that point. And that point corresponds with a y value of 1. Over here, a mapping, that's easy. F of 2 gives me 4. But the inverse, remember the inverse, you switch, you go backwards. F inverse of 6 gives me 1. Evaluate even and odd functions. This is something that we haven't really talked about in a while, okay? So you probably don't remember this. But even functions, remember I kind of drew an axis and I said, here's a guy, and let's back it up here. And an even function looks like this. So guy looks something like this. Okay. Even function. And so f of 5 equals 12 means when we go over 5, we get a value of 12. That's what that means. So on an even function, when we're looking at f of -5, that means we go over to -5. And because this is an even function, it has to be even with that other value. These two are even with each other. And so f of -5 equals 12. I think that's an interesting result of odd and even. An odd function. So the next one is odd, right? So the next one is odd. If you think about an odd function like the disco function. So again, if you imagine like somebody standing with their arms there, I don't know if that's important or not, but I like to think of it that way. Again, f of 5 equals 12. If I go over here, 5, it corresponds with the point that's up 12. All right, f of 5 equals 12. So f of -5 means we go the other way, -5, and that corresponds with this point down here, which is -12. So odd even, it really helps me if I draw this picture, okay? An even function, the arms are in the same. They're either both up or they're both down. An odd function, one of them's up and one of them's down. And so you can look at it this way. When these two are opposites, these two are the same. But when these two are opposites, these two are opposites. Evaluate inverse functions. We've already kind of done this before, but when we talk about inverses, we switch the x and y. So that should make sense. F of 5 equals 12, so f inverse of 12 equals 5. We're just switching x and y. So f inverse of 4, if I'm looking at that graph, this is a graph of f, by the way. And so you don't go 1, 2, 3, 4. You're actually going 1, 2, 3, 4 because x and y are switched. So we are at this point. 1, 2, 3. It's 1, 2, 3, 4, 5, 6. F inverse of 4 equals 6. So you're switching the x and the y. give the interval on which the function is increasing, decreasing, and constant. All right, so I think it's pretty obvious that this is the part that's constant, this is the part that's decreasing, and this is the part that's increasing. We read a graph from left to right. We read a graph from left to right, and that's what it looks like. But when we talk about the interval, we're talking about the domain. So this piece, remember there's an arrow there. This piece, if you squash it onto the x-axis, looks like this. And so that's 1, 2, 3, 4, -5 right there. So that part of the domain, the constant part of the domain, is going from -infinity to -5 bracket. This part is decreasing. But again, what we want to do is we want to look at what it looks like on the domain. We want to look at the x. That appears to be going from -5 to 0. So the part that is decreasing goes from -5 to 0. It is very tempting for people to look at the y-axis and say something like it goes from 7 down to 0. They go like it goes from 7 down to 0, but I'm not looking at the y numbers. I only look at range when it asks me to look for range. If I'm looking at intervals, I'm looking at domain. So then there's this last part right here. This is the part that's increasing. That corresponds with this part of the domain. That seems to be going up or increasing from 0 to infinity. Okay, it's been a while. Find the slope. Every one of you in here should remember the slope formula. I'm not big on memorizing formulas, but this is one of them that you should have memorized. You have done this kind of problem a million times in your lives, just not very many times in this class. This is something you should remember from Algebra 1, Algebra 2, probably had it in geometry as well. Y2 is the second y value minus y1 is the first y value over x2 is the second x value minus x1 is the first x value. Minus minus is plus, so -2 plus 12 is 10. Minus minus is plus. I've got 2 plus 4 is 6. I would reduce that fraction. I get 5/3. That's the slope of the line. Positive number slope tells me that it goes uphill. Write an equation of the line through 410 with a slope of m equals -3. When I gave this quiz, I was disappointed with the number of people that seemed to have no idea how to do this. All right, you've done this before a million times. All right, maybe not in this class so much. We've done it once or twice, but you've done this problem and you should know how to do this problem. I've got two different ways of doing it. Some people prefer to start with mx plus b. Others prefer to start with point slope form, which is y minus y1 equals m times x minus x1. I kind of prefer the second way, just in case you've got fractions. I think it's easier to deal with the fractions, but whatever. When I'm looking at this, I've got an x number and a y number, and I've got an m number. So I plug those in. My formula goes like this: y minus my y number equals my m number times x minus my x number. Usually you're going to put it in slope-intercept form. That's what they're going to ask you to do. We're going to distribute -3x plus 12. You're going to add the 10 over. That's going to give me y equals -3x plus 22. So if you do it the other way, some people prefer to say, well, I've got a y number, and I've got an m number, and I've got an x number. I just don't have that b number. So we can find the b number. This is the way I always used to do it. Add the 12 over. That's going to give me 22 as my b number. And now I can write down my equation. I've got my m is -3, and I've got my b is 22. Either way you want to go, it's the same thing, -3x plus 22.